Hello everyone, welcome back to Diksha Vedantu Foundation channel, and today I am going to discuss about the previous year questions of the chapter electricity in 99% in 99 days, a program specifically designed for you to achieve 99 marks in your upcoming 10th board final exam. And if you have not watched our chapter discussion, you can happily go back. Yesterday and day before yesterday I have discussed this chapter into two parts. You can check those two parts. Today I am going to discuss about the previous year question from this chapter electricity. Okay, so what all we are going to discuss, let's look into that. So we will be discussing about 5 MCQ questions. MCQ questions are slightly important from this chapter. Then also we will be discussing assertion and reason based question in case they are being asked from this chapter. There will be short questions, 2 marks, 4 questions of such that, and there will be short answer type questions. There will be 3 marks question for 3, and there will be long answer type questions, question 4. There is no such demarcation between long answer type and case based question, because there is no such case based question from this chapter. Sometimes they mix questions from the chapter that we discuss is magnetism. So specifically from this chapter we will not see any case based questions. Sometimes the long answer type questions will be asked in the format of 4 marks questions. So we will be discussing long answer type questions only from this chapter, and they can come as either a long answer type question or they can come as a case based question. Both way is possible. Okay, now let's start with the MCQs first. Unit of electric power may also be expressed as, electric power is also expressed as kilowatt hour. Okay, kilowatt hour is the common unit of electric power consumed in our household. So kilowatt hour is the unit. Next is the commercial unit of electric energy is. The commercial unit of electric energy, again kilowatt hour, that is the same answer. Okay, question pattern, question form is different but the same question. Now, which of these materials would you use advise in the heater elements of an electric heating device? So, in heater device we will advise to use a particular material called nichrome. So, nichrome is a material which is very commonly used in electric heating element because it has a high resistance and very high melting point. So, it does not melt, it does not, it can withstand amount of heat, whereas copper, aluminium and silver, they are very good conductor, low resistivity. So they are not super useful if you are designing an heating heater, electric heater. Next question is, a complete circuit is left on several minutes, causing the connecting copper wire to become hot. As the temperature of the wire increases, the electrical resistance of the wire. So as the temperature increases, we have discussed that the electrical resistance increases. So electrical resistance will definitely increase because temperature is increasing. Okay. Next question, when a 4-volt battery is connected across an unknown resistor, there is a current of 100 milliampere in the circuit. The value of the resistance of the resistor is. So here the voltage is given as 4 volt. Current is given as 100 milliampere. What is the meaning of milliampere? Milliampere is nothing but 10 to the power of minus 3, or in other words, don't use 10 to the powers. If you are not familiar with what you have to do, you have to divide it by 1000. Okay, ampere. Okay, milli means divided by 1000, right? So just cancel. So it will be 0.1 ampere. So current is known, V is known, we will use Ohm's law, V is equal to IR, or R is equal to V by I. V is 4 volts and current is 0.1 ampere, so this will be 40 ohm. Okay, 40 ohm is the answer. Okay, now let's move on to the next question. A given length of wire is doubled and this process is repeated once again. By what factor does the resistance of the wire changes? Very interesting question. And you should remember that when you stretch the wire, given length of the wire, when you stretch it, okay, what happens? Very interesting thing happens is that its width decreases. Okay, if its length, say initial length is L, final length is 2L, then it's if the initial area is A, then this new area will be A by 2. Area increases as you increase the length. Okay, so if you double the length, then area will be half. Similarly, this process is repeated again once more. So now the new length is basically 4L. So basically you have increased the length to 4 times. So first you stretched it to 2L, now you have stretched it to another 2L. So total length is now 4L, and the area will now be A by 4. Right? So as you increasing the length, the area will be proportionally decrease. Right? Now we know that R is equal to rho L by A. Okay, so initially this is the resistance, this is R. Final resistance R dash is basically rho 4L divided by A by 4. So you might say that if I increase the length 4 times, then resistance will be only 4 times. No, actually it will be 16 times. 16 rho L by A, so it will be 16 R. So correct answer is 16 R. I think there is a mistake here, this will be 16 R. So correct answer is 16 R. Okay, so as you increase the length 16 times, 4 times, the resistance will increase 16 times. Okay, now next question. A fuse wire is always connected in parallel with the main line. Fuse is a device which generally disconnects when there is a fluctuation of power happens in the circuit. Right? If a current larger than the specified value flows in the circuit, fuse wire melts. Yes, so that is the assertion, the fuse wire always connected. Actually no, my mistake, fuse wire is not connected in parallel. Okay, so for example, suppose there is a device, say a fridge is there. Okay, this is the fridge. Now if you connect the fuse this is the fuse parallel. Okay, if there is a more current passes through this fuse, it will melt, so it will disconnect, but the fuse is already connected in the circuit, so it will continue to function. So there is no role of the fuse to protect this device. To protect this device, the fuse has to be connected in series, right? So protect this device, the fuse has to be connected in series. In our revision video on a Saturday, I will be discussing a little bit more about fuse. This fuse exactly not explicitly mentioned in your chapter, but I found this question, it was in sample question paper 2021. So I have included this. So I will be discussing about fuse a little bit more on our Saturday revision class, so don't miss out on that. Okay, so reason is correct. Okay, if current larger than the specified value flows through the circuit, the fuse wire melts. So fuse wire melting is basically protecting the device. It melts, it burns itself down to protect the device which is connected with it. Nowadays we generally do not use fuse, we use something called magnetic circuit breaker, MCB, which magnetically breaks the circuit, and instead of replacing the switch, replacing the fuse every time, you can simply reconnect it once the current is stable. Okay, so that is what is currently used, MCB, you should remember that term. So assertion is incorrect, it should be series. Okay, and reason is correct. So assertion is false, reason is true. So correct answer is option D. Now let's look into the next question. An electric appliance with metallic body have 3 connections, whereas an electric bulb has 2-pin connection. So you may have seen, if you have seen any devices, for example in your computer PC, if you are using a PC or your laptop, okay, laptop connector, laptop charger, they have 3 pins, whereas your mobile charger has only 2 pins. right? So why there is a difference? Some quantities have 3 pins, some items have only 2 pins, some quantities require 3 pins. What is the reason for that? Okay, so let's see the reason. The 3-pin connection reduce the heating of the connecting wires. It has nothing to do with the heating of the connecting wire. We will see in our magnetic effect chapter that the 3rd pin actually works as a ground. Okay, it connects the household circuit to the ground, so that the excess amount of current, in case there is any leakage, any excess amount of current flowing in the circuit, instead of electrocuting the user, the extra amount of current actually passes to the ground. Okay, there is a 3 wires generally used in our household circuits. Okay, one is live wire, which is basically carries the current. There is a neutral wire which takes back the current, and there is a ground wire. Okay, ground wire actually grounds the circuit. Few circuits actually require grounding. Okay, for example, the metallic body, the fridge with the metallic body, it requires 3-pin connection. Why? Because otherwise, if there is a leakage of electricity, the metallic body will be electrocuted. Okay, and some devices require because it is the circuit requirement. Okay, for example, laptop requires 3-pin plug, otherwise it will be short circuited. Some of the components will not work properly inside the laptop, but battery charger device of your mobile phone does not require a ground. Okay, so that's why you do not need 3-pin connection. So bulb on the other hand only requires to glow, it does not have anything else to do, so that's why it is only a 2-pin connection. So the assertion is correct, reason is false. So assertion is true, reason is false. Next question, when a wire is pulled to the double its length, its resistivity remains the same. Okay, so obviously if you change if you saw the problem that we have solved a few moments back, we only change the length and the area, right? Rho L by A. So rho will remain same, okay, because it is a property of the material. It does not change on changing the length, changing the width. It only changes if you change the material itself or if you change the temperature. Okay, so resistivity will remain same. Resistivity depends on the nature of the material and temperature. Temperature they have not mentioned, but that is correct. So reason is correct, assertion is also correct. So both assertion and reason are correct, but and it is a correct explanation of the assertion as well. So both are correct and both are correct explanation. So why is the resistivity remains same? Because resistivity is a property of the material. That's why it remains same as long as the material is same. Also, they could have added the temperature part, but unfortunately they have not added the temperature part. But in your exam, if the same question comes, they might say add the temperature part as well. But even if without the temperature, this statement is also correct, and this is also explaining the fact that why resistivity remains the same. Now, if you all are someone who is struggling to too much about your future and you are thinking what to do after my class 10th board exam is over, should I choose science, should I choose commerce? If I choose science, what should be my focus on, what should be my end goal? End goal is very important, because without end goal you might lose your path towards your future. So what you have to do, you have to register for this very important event happening at Diksha schools every Sunday. That is DSAT. What is DSAT? DSAT is Diksha Scholastic Aptitude Test. Okay, what is the happening here? Here you are getting a 60-minute lecture. After the 60-minute lecture is over, there will be a doubt clearing session that we are calling orientation session. If there are any doubts you might have from that lecture, the teacher will clear all those doubts. Once the doubts are clear, then based on that lecture there will be an aptitude test. Once the aptitude test is over, based on the results of the aptitude test, there will be a counselor available to you. He will guide you for your future. Okay, he will say, okay, if you prepare for JEE in future, you will be doing very great. Or if you pursue NEET, then you can become a doctor. Or you want to become an engineer, then you should focus on KSET. Okay, or maybe science is not for you, you should focus on commerce or other subjects. So everything will be clear if you appear for this DSAT test. It is happening every Sunday on our Diksha campuses. So only thing that you have to do, you have to fill up this form. The link is given in the description. mention more about this at the end of this video. Now, if the proportional potential difference across the two ends of the conductor is 5 volt and current through it is 0.2 ampere, then what is the resistance of the conductor? So potential difference across two, now we are dealing with 2 marks question. As you will see, they are very easy, simple questions. The potential difference across the two ends of a conductor is 5 volt. So potential difference is given 5 volts and the current through it is 0.2 ampere. Current is 0.2 ampere. What is the resistance of the conductor? Very simple. R is equals to V by I. I hope you can directly write this formula now after solving so many problems, after revising this formula so many times. I hope you are familiar. V is equal to IR. So now you can directly use this formula. Okay. So V is 5. I is 0.2, so it will be 50 by 2, that is 25 ohm. Don't miss with the units. Units is very important when you are solving any sort of numericals, and all the questions coming from this chapter are type of numericals only. Okay, so for example, this question: a student has 2 resistors, 2 ohm and 3 ohm. She has to put one of them in place of R. Okay, R2. So he has two resistors. One is 2 ohm, one is 3 ohm. Okay, and already one resistor is already fixed. This 4 ohm resistance is already fixed. So what he can do, he can only replace this resistor. He can only replace this resistor either with 2 ohm or with 3 ohm. Okay, the current in the current that she needs in the entire circuit is exactly 9 ampere. So current in the circuit that she needs is 9 ampere. Okay, show by calculation which of the 2 resistors she should choose. So first, this is a tricky question. So what we have to do, first we have to choose the first resistor 2 ohm, and we will see what is the current. Okay, so let's see what is the current if we choose if we choose 2 ohm. So first we will calculate 2 ohm. If we get the answer, then definitely that will be our answer. We can conclude there. In case it is not, then we have to do for 3 ohm as well. Now if this is a 2 ohm resistor, suppose this is a 2 ohm resistor. Now as you can see, these 2 resistors are connected in parallel. So parallel is not always like this. So you may have seen, okay, parallel means they are connected like this. This is only parallel connection. No, parallel can be connected. This is also parallel. Okay, this is also parallel. Okay, sometimes you have to identify how parallel and series connections looks like. Okay, this is an example how parallel connection looks like. Now because as I said, if one resistor ends, both resistors starts from the same point and end at the same point, then we say they are parallel combination. So in this case, both resistors are starting at here. This resistor is starting here. This resistor, even though it appears to start from here, this is also starting here. Why? Because this is just a connecting wire. So starting point for both resistors are same. Similarly, ending point for both resistors are same. In case there was some other resistors in between, then we could not say that they are directly connected in parallel, right? Now, so first 2 ohm is there, 4 ohm is there. What is the equivalent resistance? Equivalent resistance for 2 ohms in parallel, 2 resistance connected in parallel. I taught you a shortcut method, that is 4 times 2 divided by 4 plus 2. Okay, R1 R2 divided by R1 plus R2, that is 8 divided by 6. So 4 divided by 3. So 4/3 is the equivalent resistance. Right, now what we have to do, we have to calculate the current. So V equals to IR, or I equals to V by R. Let's see what is the current, that we get. So V is given as 12 volt, R is 4 by 3. Okay, so 12 divided by 4 times 3, So 3 3s are 12, 3 4s are 12, so 3 3s are 9 ampere. So this is the 9 ampere. We required 9 ampere. So we can say that we have to add, we can choose, we need to choose, not we can, we need to choose 2 ohm as R2. Okay, in case this answer fails, suppose they have given answer such that this is not correct and this is not correct, then what you can do, you have to choose the 3 ohm, and this is the simplest way to solve this problem. There is a way so that you can directly get the value of the resistor, but that is a longer way and a complicated way. Okay, if you are interested in that kind of solution, mention that in the comment below. Maybe in a future video I will show you how you can directly get that resistance. That is a complicated video for most of you, that is not suitable. This is the direct approach. Calculate the resistance, which is much easier. After calculating the resistance, you calculate the current, and if it is matching with the given current, then definitely this is the answer. In case this is not matching, then you have to choose the other resistance and calculate it again. But you cannot leave the answer saying that okay, because 2 ohm is not matching, and then we have to choose the 3 ohm. No, you have to show the calculations. Okay, in case both of them are not giving you 9 ampere, then you have to mention that none of them can be used, right? So be careful, don't just mention that okay, because 2 ohm is not matching, so 3 ohm will be the answer. No, you cannot do that. Now next question. 360 watt incandescent bulbs are connected in parallel. Calculate the total power consumed. Now suppose that one of the bulbs is fused. What will be the total power consumed now? So now we have 3 60 watt bulbs connected in parallel. Okay, now when they are connected in parallel, what happens is each of them will burn their optimum power. So each of them will be absorbing 60 watt power. That is the beauty of parallel combination. Our household circuits where you switch on lights, fans, etc., ACs, TVs, they are all connected in parallel combination. Okay, they are not connected in series, they are all connected in parallel combination, and they individually will consume, all of them will consume the 60 watt power. So the total power consumed will be 60 plus 60 plus 60, right? So total power will be 180 watt, right? Now if one of them is fused, suppose this bulb is fused now. So this bulb is fused, so this bulb is gone, but in parallel combination, if one is fused, does not matter, other two will continue to work and they will glow with their own power. After one fused, the new power consumed will be 60 plus 60, that is 120 watts. Okay, so once one bulb is fused, remaining two will continue to glow and they will continue to absorb the power. So 120 watt power will be consumed. Now if they are connected in parallel, connected in series, okay, if they are connected in series and one bulb fused, then all of the bulb will stop working. That is the factor about series connection. Also the power consumed will vary based on their resistances. Okay, you cannot simply add them like that we have done in this case. Okay, each resistance will consume different amount of power, and that will be a completely different kind of problem. Parallel one is okay, parallel connection. But if they ask you, suppose in an objective, in an MCQ, they ask that 3 bulbs are connected in series, one bulb fused, what will happen to the circuit? So all the bulbs will stop glowing. Okay, in parallel combination, no matter how many bulbs is fused, whatever is still intact, they will continue to function, right? That is the beauty about parallel combination. Now next question, answer the question based on the electric circuit shown below. So this kind of question can be asked as a case based question as well. There will be slightly bigger statement. there will be circuit diagram as same as this. Okay, slightly bigger statement to confuse you, to distract you, otherwise just read the questions and answer it. Okay, so all the 4 bulbs are identical. So bulb 1, bulb 2, bulb 3, bulb 4, all of the bulbs are identical. Now let's see what is the question. How does the voltage reading on voltmeter 1 compare to the voltage reading on voltmeter 2? So what are the voltmeter? So there is a voltmeter here, V1, there is a voltmeter here, V2. Now as you can see, I guess there is one small mistake, which is they are not connected like this. Okay, there should be no connection, otherwise this question has no meaning. Okay. Now so what is the voltage reading about this voltmeter and this voltmeter? Now you might say, okay, this is connected directly across the bulb, whereas this is directly connected in the circuit, so they will have a different value. No. So if you see these points from here to here, they are connected by a connecting wire. So you can say that this bulb is also, this voltmeter is also connected here, this voltmeter is also connected here, but only from the other side. So both voltmeter will have the same reading. So first question is, both voltmeter will have the same reading, so V1 equals to V2, because they are connected across the same thing. Okay, you can ignore the straight wires. Okay, you can ignore because they have no resistances. So straight wires you can always ignore. Right? Now next, identify the bulbs through which current equal to the reading of the ammeter flows. Now let's see what is the ammeter. Ammeter is connected in series. Okay, ammeter is connected in series, so which all other bulbs are connected in series. So these two bulbs are connected in parallel. So in parallel means they will have different amount of current flowing through them other than this. So current in the circuit, say I. Current in the circuit, say I, flowing in here. So this current will pass through the ammeter as well. What all are the bulbs that is connected in series? So bulb 3 and bulb 4, they are connected in series. So bulb 3 and bulb 4 will have the same current as that of the ammeter. So the answer to this question will be bulb 3 and bulb 4. Okay, bulb 3 and bulb 4, they will have the same current as that of the ammeter. Now two lamps, one rated 100 watt at 220 volt and other 200 watt at 220 volt are connected in series, number 1, and number 2 connected in parallel to the main supply of 220 volt. Find the current drawn in each case. Okay, so this question, even though it starts with the bulb, this question is actually combination of resistances, nothing else. Only thing that you have to do, you have to calculate the resistances of these bulbs. So first is bulb 1. What is the resistance? So power is given and the voltage rating is given. When power and voltage rating is given, you can calculate the resistance. How? We know that power is basically VI. Okay, I is not given, but we know that I is equal to V by R. Right? So if you put that, you will get V square by R. Right? So this is the relationship that we need to use, or R is equal to V square by P. I don't ask you to remember this equation directly, but you know that power is Vodafone Idea, okay, and current is V by R. So from there you can put this value and you can calculate the R value. If you remember this formula directly, very well, but if you don't remember it, that is also fine, as long as you know these two formulas individually. Okay, this is Ohm's law, by the way. Now V for bulb 1, V is given 220 volts. So 220 into 220. Why? Because 220 V square is there, right? So multiply it twice. Power is given 100 watt. So 100. So 1 0 cancels, 1 0 cancel. There is no square of the power. So don't mistake it by saying okay. And now this will be 22 times 22. So 121 into 4. 121 into 4 means 484. So resistance of the first bulb is 484 ohm. Okay. So how did I did it? So if you don't remember 22 into 22, then you remember that 22 is basically 11 into 2, right? So you can write 22 into 22 as 11 into 11 into 2 into 2, right? You can do that. Now 11 into 11 is 121, we know that, right? 2 2s are 4. So now just multiply it. 4 1s are 4, 4 2s are 8, 4 1s are 4. So like that you can do it. This is a way of solving without using calculators. Okay. Solving without calculator is very, very handy, and it will help you in a long run. Now for bulb 2, I can simply use the same formula. Okay, I don't need to derive the formula again. Okay, so this is R1, say R2 is equals to V is same, 220 into 220, and power in this case is 200 watt. Okay, so 200 cancels. One of the 22 will be giving me 11, so 22 into 11. So 121 into 2, that is 242. Okay, so 242 ohm is the resistance of the second bulb. Okay, so we have calculated the resistances of the bulbs. Now what we have to do first, they are connected in series. So when they are connected in series, now we will treat them as simple resistors, R1 and R2. Okay, and the voltage applied is 220 volt. This is case 1. 220 volt, right? Now what we have to do, we have to find the total resistance. Total resistance in this case is basically R1 plus R2, that is 484 plus 242, that is 6, 8 4s are 2, in hand 1, 6 7, 726. So this is the R equivalent, and you can calculate the current by V by R. So what they have said, find the current drawn, right? Current drawn is 220 volt divided by 726. Okay, so you can cancel, I think 11, it should be multiple of 11, so 20 and 6 11s are 66, 6 11s are 66. Okay, so double 6, so it will be 10 and it will be 33. So 10 by 33 is the current in the first case. Okay, you don't need the exact value. Now for the second value is important. So what we will do, we will just keep these values intact and we will erase this. So what is the value of R1? R1 is 484. And what is the value of R2? R2 is 242. Okay. Now what we can do is we can connect them into, now part 2, connect them in parallel. So if we connect them in parallel, now what? So this is R1, this is R2, and this is 220 volt. So what is the R equivalent in this case? R equivalent in this case is R1 R2 divided by R1 plus R2. Okay, I told you how can you calculate the equivalent resistance when two resistors are connected in parallel. This formula is valid only for two resistances, right? So R1 R2 is 484 into 242 divided by R1 plus R2 we have already calculated, 726. Okay, 726. Okay, now we can cancel 66, 11. Okay, we are cancelling with 11. So 11, 2 11s are 22, 2 11s are 22. Okay, so now let's cancel. 3 22s are 66. Now can we cancel it with 3? I don't think so. 3 ones are 3, 18, 3 6 are no. We cannot cancel it with 3. So the answer of the R equivalent will be 484 divided by 3. Don't worry about it. Don't worry too much about the value. Okay, because we have one more step left. So that is to calculate the current. So current is basically V by R equivalent. So V is 220 volt. We already know that. So 220 volt divided by 484 by 3. So 3 will go up, okay, in the numerator, right? Now let's cancel. 11 2s are 20, 2 11 4 11s are 44, 4 11s are 44. Okay, so another cancels. It will be 10 and it will be 22. So 30 divided by 22 ampere is the second answer. So in the first case it will be 10 by 33 ampere. In the second case it will be 30 by 22 ampere. Okay, clear? It's a slightly longer problem. That's why it is a 3-mark question, not a 2-mark question. Okay, now the potential difference across two ends of a circuit component is decreased to 1/3 of its initial value. Okay, while its resistance remain constant. What change will be observed in the current flowing through it? Name and state the law which helps to answer this question. So first of all, they said that initially voltage say was V. It is reduced to 1/3 of the final initial value. Now resistance remains same. What will happen to the current? So the first case, what is the current? First case current was V by R, right? In the second case, what is the current? So now say current is I dash, it will be V by 3 divided by R, right? Because R is constant. So 1/3 V by R or 1/3 I. So current will become 1/3 of the initial value. So as you decrease the voltage to 1/3, the current will also be decreased to 1/3, right? Now what law it is? It is Ohm's law. Okay, and the statement is if temperature and other physical constants remain same, then the current through a circuit is directly proportional to the applied voltage, right? So that is the Ohm's law. So from Ohm's law you get V is equal to IR, R is called resistance. So this is the law. Next question, draw schematic diagram of a circuit consisting of a battery of 4 1.5 volt cells. Okay, so 4 1.5 volt cells. So let's start. We have a cell, one cell, two cell, 3 cell, 4 cell. Okay, all of them are 1.5 volt. Okay, now a 5 ohm resistor, a 10 ohm resistor and a 15 ohm resistor and plug key all connected in series. So this is very, very important. So first is a 5 ohm resistor, next is a 10 ohm, and last is a 15 ohm. Okay, and there was also a plug key. So once they ask you to draw the schematic, you have to draw the schematic properly. Okay. In this case, what you can do, you can draw 1.5 times 4 volt. So total voltage will be 6 volt. As you can see, as they are connected in series, total voltage will be just addition, right? 1.5 plus 1.5 plus 1.5 plus 1.5, or 1.5 times 4. So adding same number 4 times is basically 4 times the one of the number, right? So this is the schematic diagram. If you draw it, you will get 1 mark. Now find the electric current passing through the circuit and the potential difference across 10 ohm resistor when the plug key is closed. So plug key is now closed. So what you have to do, you have to find the current passing through the circuit, total current passing through the circuit, and potential difference across 10 ohm. So to calculate the total current, first we have to calculate the total resistance. What is the total resistance? They are connected in series, so the total resistance will be simply adding them. So it will be 15, 15, 30. 30 ohm is the total resistance. Now what is the current? Current is volt divided by R equivalent. What is volt? Volt is 6 volt. So 6 volt divided by 30 ohm, 1 by 5, so 1 by 5 ampere, or 0.2 ampere. Okay, 1 by 5 is equals to 0.2. Now what is the potential difference across? This is the part 1. Part 2 is potential difference across 10 ohms. So potential difference across 10 ohm is basically the resistance 10 ohm times the current. Okay, resistance 10 ohm times 0.2, that is 2 volt. Okay, so 2 volt is the voltage drop across the 10 volt resistance, right? So you have to practice these questions again and again. You have to check this video once more if you are having difficulty in solving such questions. Now next question is also a circuit based question. In the given circuit, A, B, C, D are 4 lamps connected with a battery of 60 volts. So here as you can see, A, B, C, D, they are all connected with a battery of 60 volts. Okay, analyze the circuit to answer the following question. Okay, what kind of combinations are used? A, B, C, and this is D. Okay, somehow numbers are missing, so I am marking them. Now let's see the question. What kind of combination are the lamps arranged in series or in parallel? So as you see, they are connected, starting point of each of the lamps, they are connected to the same point to the battery, right? Similarly, ending point of each of the lamp is connected to the same point of the battery. Even though the symbol of the battery is wrong in this case, this is given as a capacitor, so the battery will have one arm longer than other, obviously. Okay, so let me correct that. Now so they are connected, same point is connected across same points, so basically this is a parallel combination. So this is a parallel combination. Okay, next, explain with reference to your above answer what the advantages of any two of this combination of lamps. So combination of lamp, the advantages are, first of all, each of them will be functioning independently, that is each of them will glow with their maximum possible brightness. Okay, they will not dim or they will not reduce. The current will be individual for all the components, right? They are all operating under the same potential difference, so they will operate with the maximum power output. So first point is they will operate with maximum power output. Second point is if one of them is fused, then other will still continue to work as they are connected in parallel. They are independent from each other. Parallel combination means they are independent from each other. Series connection means they are dependent. So basically you are in the care of your parents. So you are in the series connection your parents. But your parents are in parallel combination. They can survive even if you are contributing to your family or not. Right? See, but you are dependent on your parents. So if your parent says, okay, no pocket money for you, you will not be able to eat whatever you are eating outside. I know what you are doing every day evening, right? So So that is the fact for parallel combination. Jokes apart, so parallel combination is basically when they are independent from each other. So they will have the maximum power output and they can function even if one of them is fused, right? So that is the parallel combination. Now explain with proper calculations which lamp glows the brightest. So which lamp glows the brightest? How can we do that? To do that, first of all, you have to calculate the power for each lamps. PA, PB, PC, PD. Okay, what is the power? Power is Vodafone Idea. Okay, so each of them will have different current passing through them. Voltage will be same. V is same for all the bulbs, right? Current is different for all of the bulbs. So first calculate PA. Now if you see PA and PD are same. So if you calculate PA, you can calculate PD as well. 60 into 3, that is 180 watt. So PD will also be 180 watt because current is same. Now what is PB? PB is 60 times 4, that is 240 watt. What is PC? PC is 60 times 5, that is 300 watt. Okay, so as you can see, they will have the highest power. Now they have asked you calculate the total resistance of the circuit. Now you might think, okay, this is a difficult question. Total resistance means I have to calculate the resistance of individual all these resistors, then I will be adding the resistors in parallel combination. Oh my god, that is a very long problem. Actually no, there is a trick to solve this question. So what is the trick? The trick is, here they have given you individual currents, okay, 3 ampere, 4 ampere, 5 ampere, 3 ampere, right? So what we will be doing, we will try to find the total current in the circuit. So total current, remember that total current which is getting input into the circuit, the same current is coming out in the circuit. And somehow if you can construct a circuit such that there is a 60 volt battery and one resistor connected such that the same current I is going in and the same current I is coming out, then this is basically your R equivalent, right? If we can find this I, so how to find this I? I is nothing but sum of all these individual currents, right? So I is basically sum of 3 plus 4 plus 5 plus 3. So I is 3 plus 4 plus 5 plus 3, that is 7, 12, 15 ampere. I is 15 ampere. So we know that potential is 60 volts. So V equals to IR, or R is equal to V by I, or 60 divided by 15, that is 4 ohm. So 4 ohm is the total resistance of the circuit. So if you know this trick, you don't need to worry too much. You can simply use this combination. Ohm's law is applicable no matter you know the resistance, you don't know the resistance, right? So what you have to do, you have to find the first, you have to find the total current. If you know the total current, that is fine. So total resistance is same. That is why the concept of equivalent resistance is so beautiful. Now question number 18. 3 resistors in a circuit are attached as shown here. The resistances of F and G are 10 ohm and 5 ohm. So F is 10 ohm and G is 5 ohm respectively. Okay, the resistance of E is unknown. Resistance of E is unknown. These resistors are connected to a battery with a potential difference 6 volt. So they are connected with a battery of 6 volts. Some symbol error happened. So this is a 6 volt battery. What is the term used to describe such arrangement of resistors? So this is what is the combination. This is easy to answer. This is common as your books. So as you can see, all the resistors are connected at the same point. So basically you can say that they are connected in series combination. I said series and you believed in series, right? So that means you are not paying attention. You are not focusing. This is a parallel combination. don't blindly listen to anything, right? What is the resistance of E if 0.3 ampere current flows through it? So 0.3 ampere current is flowing through it, and they are asking what is the resistance. 0.3 current is flowing through it. So we know that Ohm's law is applicable individually to all the components because they are independent, right? In parallel combination they can be considered independent. So this 6 volt, same voltage is applied across this E as well. So for that we can say that, okay, voltage across E is the same as the applied voltage, that is 6 volt, right? So V is equal to IR. Okay, so RE is equal to VE by I. What is VE? VE is 6. What is I? I is 0.3. Okay, so 60 by 3, that is 20 ohm. So E is basically 20 ohm. Now next is, what is the total current flowing in the circuit? Now to find the total current in the circuit, in this case you have to find the equivalent resistance. Okay, there is no other way, there is no other shortcut. Okay, to find the total current in the circuit you have to find the equivalent resistance in the circuit. There is one more way, slightly longer but easier, but if you want that answer you have to mention that in the comment. I am not seeing any comment from you. I will not do that. I will do the shortcut way, smallest possible way, but little bit tricky. What is that? Here this is 20, this is 10, and this is 5. Okay, E, F, and this is G. Okay, so this is 6 volts. We are trying to find the total current in the circuit. So how to solve that? So we will find the total resistance. Total resistance, say 1 by equivalent equals to 1 by RE plus 1 by RF plus 1 by RG. You need to know this method as well. That's why I am solving it like this. So 1 by 20 plus 1 by 10 plus 1 by 5. So the LCM will be 20 obviously. So 1 plus 10 is 2 and 5 is 4. Right? 4 5s are 20. 6 7. So 7 by 20. But this is 1 by REQ. So what is REQ? REQ will be 20 divided by 7. Right, so REQ is 20 divided by 7. Now what is the current? So V equals to IREQ, or I equals to V divided by REQ, or 6 divided by 20 by 7, or I equals to 6 times 7 divided by 20. Okay, so it will be 10, it will be 3 to the 6, right? So 21 divided by 10, that is 2.1 ampere. So 2.1 ampere is the current in this circuit. Okay, now next question. It is also a similar looking question of the previous one, but the circuit diagram is slightly different. Find out the following in the electric circuit given in the figure. So it's a direct question. Okay, effective resistance of two 8 ohm resistors in the combination. So here two 8 ohm resistances are connected like what? So if you see, only thing that is you have to be careful, both resistances are starting from the same point and they are ending at the same point. That means what type of connection it is? It is parallel combination. So if they are connected in parallel combination, then the equivalent resistance of both the 8 ohm resistors are 8 times 8 divided by 8 plus 8, that is 4 ohm. So how I have written this directly without doing any calculation? So basically, when two equal resistances connected in parallel, their equivalent resistance is just half. If you know that, you can write it directly, but you have to show this calculation at least once. Okay, now next is current flowing through 4 ohm resistor. So what is the current flowing through the 4 ohm resistor? Current flowing through this 4 ohm resistor is same as the total current in the circuit. So how can we calculate the total current in the circuit? We have already calculated this combination. So let me redraw this circuit. So 4 ohm is here. We will ignore other parts, they are not necessary here. Okay, and these are connected like this. So this is 4 ohm, we know that. This is the equivalent resistance, that is also 4 ohm, and the battery is connected 8 volt. Okay, now what is the current? So current is basically, now what is the, these two resistances are now connected. Now these two resistances are now connected in series. So as you can see, once this resistance is ended, the other resistance is starting. So that means they are connected in series. So equivalent resistance in this case, Req is 4 plus 4, that is 8 ohm. So what is the current? Current is V divided by Req, that is 8 divided by 8, that is 1 ampere. So first part combination is 4 ohm, current through 4 ohm resistor is 1 ampere. Potential difference across 4 ohm resistance. So potential difference across this is, how to calculate potential difference? So part A, B, now let's see. Potential difference across this 4 ohm resistance is basically resistance times the current that is flowing through it. So 4 volt is the voltage drop. Now next question was power dissipated in 4 ohm resistance. So this is 4 volt. Power dissipated in 4 ohm resistance. So what is the power dissipated? Power dissipated, we know that is VI, right? Power is VI. Resistance voltage is 4 volt, current is 1 ampere, so 4 watt. Okay, 4 watt is the power dissipated. Now this is an OR question. This question was OR, difference in ammeter readings, if any. So now if you see, what is the difference between this ammeter and this ammeter? They are all connected in the series combination, series part of the circuit. They are not connected in the parallel part of the circuit. So since they are connected in the series part of the circuit, both of them will show the same reading. Okay, there is no difference in their readings. Now they will show the same reading. They are connected in series, hence they will show the same reading. So this is a confusing question maybe for you, that okay, there is some point B is marked, some point C is marked, here D is marked, here E is marked, there is a knob available, so there should be some difference between. This is a trick question. Actually not. This is a trick question. This is a double trick question, right? So you might think this is a trick question actually, but that is not a trick question, that is an easy question. Okay, both of them will have the same reading. Now let's look into the last question of today's discussion. B1, B2 and B3 are 3 identical bulbs connected as shown in the figure 12.8. So this is the figure. When all the 3 bulbs glow, a current of 3 ampere is recorded by the ammeter A. So when all the 3 bulbs are glowing, okay, the current that is recorded is 3 ampere. Okay. What happens to the glow of the other 2 bulbs when the bulb B1 gets fused? Okay, if suppose the bulb B1 is fused, nothing will happen to other 2 bulbs glows because they are connected in parallel. So you have to mention that nothing will happen. Why nothing will happen? Because they are connected in parallel. So parallel symbol is this. Okay, you can use this symbol. They are connected in parallel. Shortcut, short notation. Okay, but in exam write in parallel completely. What happens to the reading of A1 and A2, A3 and A when the bulb B2 is fused? So what will happen to the reading of A1, A2, A3? So first of all, let's start with all the combinations. What will happen to A1? B1 is now working. Okay, now only B2 bulb is fused, so A1 will remain same, Not only A1, in fact, A1 and A3 both are not changing, so A1 and A3 will remain same. What will happen to A2? A2 will be 0 because it is fused, so no current is flowing, so A2 will be 0. What will happen to A? A will decrease. Okay, one of the bulb is fused. A is basically sum of all these 3 amperes, right? 3 ammeters. So A is basically A1 plus A2 plus A3. They are connected in parallel, so current is getting added. Current is getting added means A is basically sum of all these 3 readings. Okay, now if this is fused, this one is no longer sending any current. That means this amount of current will reduce from the reading of A. Now last question, how much power is dissipated in the circuit when all the 3 bulbs glow together? So how can we calculate, sir? There is no resistance is given. How can we calculate the power dissipated? Okay, don't worry, we were given this is the voltage and we were also given the current in this circuit is 3 ampere. Right, 3 ampere was the current and voltage of the circuit is given, so power dissipated is easy. Power is Y. Okay, there is a character in a anime series, anime game. If you watch that, let me know in the comment below what is Y. Okay, V is 4.5, I is 3 ampere and it will be 15.5, 12, 13.5 watt. Okay, so 13.5 watt is the power consumed in the circuit. Now if you also like someone who is not sure where should I focus for my future, what is my end goal looks like, what is my dream, what I want to become, okay, and if you are not sure that okay, even if I try for maybe a medical examination in future, whether I will be successful or not, or if I want to take admission in a top IIT in India and whether I will get admission or not. So to tell that, to predict that future, Diksha has arranged a beautiful program, that is Diksha Scholastic Aptitude Test or DSAT. What is DSAT? DSAT is basically a 1-hour lecture. They have 3 components. First is 1-hour lecture. They will teach you about some concepts. Okay, whatever concept it is, they will teach you in a classroom. Once the lecture is over, you might have some doubts about that concepts. Okay, you can ask the teacher, what is my doubt? Sir, I didn't understand this. Or if you can ask creative questions as well. If you taught about this, but what will happen if this something is changed? So after all your doubts are clear, then there will be an aptitude tests. Okay, one aptitude test based on the lecture that you have attended, right? So there will be some different levels of questions, some intelligence based questions, some direct recall based question, and some application based questions. So once you have answered all those questions and they are evaluated, you will be assigned a score. Now if you take that score to the counselor available, they will guide you for your future options. Okay, they will tell you, okay, if you have scored this much and you have a strong aptitude for say medical exams. If you prepare for medical exams, you will score well. If you prepare for IIT exams, you will do very good. Or you have a future in engineering, you can appear for KSET exams. Okay, Karnataka state eligibility test that is conducted for all the engineering colleges across Karnataka. Okay, even many students don't take admission in national colleges, they take admission in KSET because there are very good colleges available across Karnataka. Many students from outside also comes to Karnataka for study. Right, and if you are someone like that, if you are still confused, you can fill this form. The link of this is given in the description, and ask your parents to fill this form, take the admission key and appear for this beautiful program. Okay, so I will be back with a review on Saturday, a revision on Saturday. Okay, there will be no other subjects revision because all the subjects revision are either not started yet or not or already completed. So I will be only taking the Saturday revision, but on Sunday physics and tomorrow's chemistry class will be considered for tests. Okay, so Saturday I will be only taking the revision, but Sunday tests will have physics as well as chemistry. Right, till then, bye. I will be back. See you on Saturday.